So we'll wrap up this lecture with these last two practice problems on proportion-based confidence intervals. So let's chat just briefly about that. These are the two formulas that we need. You see we've got this new symbol there for the point estimate. It's the sample proportion. And I don't think we have seen that yet. So let me put it out here. This is called P, literally it's P hat. The little hat sitting on top of the P there, and it represents a sample proportion. So what we've done up until now is used X bar, so kind of a similar symbol, P hat, X bar. The X bar is the sample mean, the sample average. Now we're going to switch our thinking a little bit and think sample proportion. So what's kind of going on here? There's really a connection to the binomial distribution with success and failure. So we're going to say that P hat is the probability of success. So we're not taking an average anymore. We're thinking just success and failure. So we take a sample, there are several data points in our sample, but each data point is either, it's not a number now, like a continuous random variable. It's either was it a success or was it a failure, like yes or no for each data point. So we'll have our sample proportion. Of course, we'll do an example in a moment. Now we've got a new formula for the margin of error. One thing you notice, we're back to the z-score. So we're going to use our normal calculator in StatCrunch. And then we've got this big square root over p hat q hat over n. Won't go into the details of where that formula comes from exactly, but you can kind of see, part of the old formula in this part of the margin of error. It's dividing by square root of n. It just happens to be the top is the square root of p hat q hat. And if you're taking the square root of both, you can take the square root of the whole thing. So we can sort of make sense now instead of like a standard deviation. Now we've got this numerator going on. So a similarity. Okay, anyway, point is we just need to know these formulas. Let's get to practice problem number 6. Okay, so here's how we can start it off. Let's go ahead and read it. A sample of 500 applications to a large nursing program included 60 from men. So right there, 500 applicants, but only 60 from men. Find the 90% confidence interval of the true proportion of men who applied to the nursing program. So just think, this is a huge nursing program. It might be some very large university. I think SDSU has a huge nursing program, from what I understand, really, really good one. So they're going to receive thousands of applications, if not tens of thousands, in a given year, perhaps from all over the world. So they took a sample of 500 of these, and from that sample of 500, only 60 came from men. And okay, we know we want a 90% confidence interval. All right. So let's try to fill in these numbers based on what they describe. And then from there, once we have those numbers, then it's going to feel very much like all of these other problems with confidence intervals. So, okay, p hat, the proportion of success. So we're going to say we need to define success. And I think the natural way to do it here is to define success, since they're talking about applications for men, that it was a, like it was I guess put simply, that it was a man who applied, okay, to the nursing program. So what was the proportion of success from our sample? Well, 60 applications came from men out of a total of 500. Okay, so we want the proportion there. 60 out of 500 looks like I didn't do this ahead of time. What's that gonna be? Comes out pretty nicely, 0.12. Okay. Okay, Q hat is the proportion of failure. Um, well, since there's only the two options, right? If 0.12 is success, how do we get Q hat? And there's kind of an idea of a complement here. We take 1 minus that, 0.88. 88%, 0.88 probability that an application came from a woman to get into this program. Okay. Moving along, N. What is N? N is just the sample size. How many total applicants are we looking at? 500. And Z. Okay, the Z. So, pause for a second. We know we're looking at a 90% confidence. So what is the Z-score that goes with 90% confidence? Well, you could certainly go to your StatCrunch calculator, the normal calculator, and make sure you're using the between setting and put that it equals 0.9 or 0.90 and have it go back. We did this very number before for the 90% confidence interval. It's 1.6449. Okay. So we got all of our crucial values. From here, we're going to go ahead and compute the margin of error. We got our Z, our P hat, Q hat, N, the square root of that whole thing. Be careful with your order of operations. You may need parentheses, say like right there, depending on your calculator. We're going to round this to 3 decimal places as it tells us, 0.024. Okay. Once we've got our margin of error, then the formula, it's off the screen now, but we take our P hat and we add and subtract our margin of error. So 0.12 minus the 0.024, 0.12 plus the 0.024, and there's our final answer for the 90% confidence interval. We're 90% confident that the actual proportion of men who applied to this program, if we were to look at all of the thousands of applications, we're 90% sure that it falls somewhere between these two probabilities. So the big thing here about proportion-based, right, now we're looking at proportions versus averages. So what is that, 9.6% and 14.4% if we thought of it that way? Okay, okay. Of course, bring any questions you have to the live. We got one more practice problem to do. It's number 7, and we're gonna mix things up a little bit now that we know how to do the typical question. What happens when they change up what we're looking for? So number 7, it says an advertisement for a product to help quit smoking claims that 70% of those who used the product had not smoked after 8 weeks of use. I think that's pretty impressive. 70% of those who used it hadn't smoked at all after 8 weeks. The study this was based upon used the 95% confidence interval, and they tell us the confidence interval to be 0.596, 0.804. Okay, so maybe, we hear this claim, you hear claims like that, that it wouldn't be unusual to hear it in an advertisement, right? Maybe you research a little more and you find that they used a 95% confidence interval, which is very typical for these kind of studies. It's the go-to. And their confidence interval came out to be 0.596, 0.804. Okay, so we know the confidence interval. What are they then going to ask? Part A, well, what is the point estimate of the study? And we're kind of build up. Really, part B is the big one. But we need to start. What is the point estimate of the study? Well, there's two ways that we can get the answer to the point estimate. So it turns out that's their claim in that first sentence, and that's probably what maybe they would advertise. 70% who used the product hadn't smoked for after 8 weeks. The sample proportion is that 70%, 0.70. Okay. Now there's another way to get the answer for the sample proportion, p hat. You could base it on the confidence interval. So they tell us, I mean, if I was to even graph it, let's say, if we just graph, say, this number line, we know that p hat, the point estimate, is always right at the center, right? And they tell us the confidence interval starts at 0.596 and it ends at 0.804. So even if you were only told the confidence interval, you could get the point estimate. What number is directly between these two? And maybe you can tell, oh yeah, 0.7 is right between them. But if maybe it wasn't so obvious, well, we could take the average, right? And that's going to give us the 0.7. Right there and straight in the middle of our confidence interval. Okay. So not quite so obvious, but maybe that makes sense. Maybe you kind of could tell that it was 0.7 from the beginning, or maybe you prefer this style. How about part B? Okay, let me read it. Oh, well, how many subjects were in the study? Hey, we saw a question similar to this back with, I think it was like a number 3 or something. How many subjects? Well, that's n, right? So we're going to use our margin of error formula because that formula involves n. That's what we're going to look for and solve for. That's our goal. And so apparently we're going to be able to tell the values for all of the other 4 parts, p hat, q hat, z, and the margin of error. And well, of course, we have p hat already. So let's see here. I think I've kind of got it laid out like this. So we just found p hat to be 0.7 or 0.70. What will q hat be? And okay, yeah, it's always the complement of p hat. How much more do you need to get to 100%? Like what's left over? These always add up to 1. All right. Hey, what is the z score here? So let's read it. It says the study was based upon the 95% confidence interval. We've got 95% confidence. What value of z goes with 95% confidence? And you might remember it's 1.96. So that one I'll encourage you, memorize the 95% confidence of the z-score. If not, of course, you can always use the StatCrunch normal calculator and work backwards. And the margin of error, the margin of error, what's that going to be here? To find the margin of error, we need to be a little bit more clever. Let's actually go back up to this drawing of this number line a moment ago. Hey, if we know p hat and we know these values, isn't the margin of error that distance? Let me draw that again. So this is 0.7. This is 0.804. This is 0.596. How far is that? That's the margin of error. And if you subtract 0.804 minus 0.7, you'll get, well, I got to do it myself, 0.804 minus 0.7, 0.104. That's how far you are shifting in each direction. Or you could take 0.7 minus this smaller number, get the same thing, right? It's all symmetrical. And okay, we're looking really, really good. We're going to plug all these values in, just like that. And our goal, of course, is to figure out the value of n. Can we solve for n? So you might feel pretty comfortable doing this on your own. There's more than one way to go about it, but maybe not. And so I'm going to walk through what I find the most natural approach. To begin, I'm actually going to divide by the 1.96 to start this off. And in the same step, I'm going to go ahead and multiply the 0.7 and the 0.3. Excuse me, I sneezed there. Wow. Okay, so dividing, multiplying here. Notice I did not actually perform the division because that would require me to round at this step, and I'd prefer to keep it unrounded for now. So I'm just going to leave it like this. Now I've got all this underneath a square root. I'm going to square both sides. And again, I'm not actually going to do the squaring here. I'm just going to write it like this. Okay, because then I'd have to round. All right. Then I'm going to multiply my n over. And I'm kind of doing two things at once. So I'm going to multiply this n over here, and I'm going to take this whole thing and divide it underneath like so. And so I've got 0.21 divided by the quantity 0.104 over 1.96 squared. You may prefer a different approach here, but I think this one works pretty good. Okay, now I'm going to just go for it, put this whole thing in my calculator, and definitely encourage you, whatever approach you took, to go ahead and compute that yourself. Make sure you get the same answer here that I do. N equals 74.59. Now, when we have a value of n is always a number of subjects, right? The sample size. It's always going to be a positive whole number. So let's go ahead and round that. I'm going to round up. We need 75 subjects. Well, it's not that we need. I guess the question is how many were in the study. They used 75 subjects in their study to come to that 95% confidence interval that we see. Pretty cool. We know how many people were in their study. That's pretty slick. Hey, does that seem like a good sample size there? Does that seem like they tested enough people to give accurate data in this advertisement? Be a lot more interesting if I could hear your responses. Yeah, I would say so. I mean, again, the cutoff is 30. So anything over 30 I think we'd say is a solid sample size, and that's 2.5 times what we you might say is the minimum. So yeah, 75, that's solid. That's plenty of data. Which leads us to part C. Now, in a question like part C, there's really not a right or a wrong so long as you're able to justify your reasons. So it says, does this product seem like it really would help most smokers to quit? Well, kind of think about what we've got. We've got that confidence interval. It was 95%. We know how many people they used in their study. Does it seem like they're trying to pull one over on us, or does it seem like they really did their due diligence and tested this thing well? I would say that there's a couple of different reasons why we can say yes, that this product really does seem like it's going to help most smokers to quit. So I gave two reasons why I think the answer is yes. They had a large sample size, so just kind of spoke about that. I'd say, yeah, 30 or more is going to qualify as large enough. But with 75, I mean that's 2.5 times. That's plenty big. And then to create their confidence interval, they were 95% confident, and even just looking a little bit further, a little deeper into that, the minimum of their confidence interval was 0.596. So they're 95% sure that the minimum probability is this, right? Just shy of 60%. It's possible, although not likely, that the actual population average once people start buying this is a little bit lower. Okay, and it's possible, but not very possible. It's like 2.5% that it's lower than this, 2.5% that it's above their 0.8. So I'm not looking at the higher numbers. I'm just thinking, what's the minimum, right? Like what is the bare minimum probability that this is going to help somebody? And they say they're 95% sure that it's at least 0.596, like 60%, just shy of 60%. Now you could argue on the upper side, um, that it goes all the way up to 0.8. But I'm just thinking in this context, we want to look at the minimum. In a different context, we might want to look at the maximum. But here, we're 95% sure that it's at least this many. And I think for those two reasons, we can say, yeah, this seems like a solid product, and they definitely did their diligence in their research. Well, that is the end of confidence intervals, chapter 8. Okay, we really made a big turn with this chapter. So, what might we do next in chapter 9? We will see. See you in the live session.